Okay, I think we'll go ahead and get started. We have one more day of reviewing, okay? And then after that, all next week, which would be, what is that, May 5th, 6th, 7th, 8th? No. So May 6th to May 10, okay? We start going over all of our different applications or problem solving applications that we've done all semester. So if you had to summarize that, what was our first set of problems? We'll go over this again, but I just want to ask you because it's something that you didn't expect to have to answer. That's correct. So how would you apply that slide rule? Why was it important? Think of like a whole bunch of circles and, right. We call that the Bohr model and configurations. Okay. Then after that, what did we move on to after the configurations and Bohr models? Say that again. Okay. Electron dot diagrams, we did that. And if we really wanted to be specific, you continually build upon those electron dot diagrams. We use them, you just don't realize it, okay? And then, what about naming compounds? Do we remember that? That was probably included in the same chapter, I believe. Then after the Bohr models, the configurations, the dot diagrams, the naming of inorganic compounds, then we moved on to what? Kind of like balancing books. Yeah, chemical reactions and balancing equations. And then after that, we've arrived to what we're discussing now, which is organic compounds. That's why we wanted to state you're naming inorganic compounds, which could be calcium chloride, sodium chloride, copper 2 sulfate, things like that. That is what we mean by that of inorganic compounds. So, but as far as what we've learned so far, if we were to see a formula like this, for instance, I'm going to draw all three of these. Now, the better way to determine this is these are three different organic families. Okay? Now, you wouldn't be able to tell that by looking at the molecular formula, but since they all have 5 carbons, can these be isomers of one another? They cannot. Why is that correct? Yeah, because our hydrogens are different. Okay? So in each and every case, we can draw our 5 carbons. Okay, I think I just drew 6, didn't I? Okay. I was running into that galactose, and I thought I might need the extra room. Okay. When we said you are continually using those dot diagrams because of valence compounds, carbon is in which column? The 4th column. So once we say that, we know carbon wants how many bonds? Okay, so this one's probably the simplest, even though it's got the most number of hydrogens, because this is the first organic family we learned. And that is, these all begin with Al. They're not aldehydes. Say that again? That is one of them, but it's not the first one. if these are all single bonded, what does that tell you? Yeah, these are the organic family alkanes. Okay, and then when we said your valence number or your electron dot diagrams, we know each carbon wants how many bonds. Okay, so we've exasperated one in between each one of these, but we have 12 hydrogens to contend with. So just by doing simple math, what is 5 times 2? So on the top and bottom, 2, 4, 6, 8, 10. Where do our last 2 come from? On the ends. So here is the compound pentane, because we said this is an organic family called alkanes. So you pick the top or the bottom now. Okay? Do you think, if you had to guess, of all of our remaining organic families, it's related to this, it's similar to, oops, I forgot the K. Okay? Then what 2 possibilities might it be? Alkenes and alkynes. Okay? So we picked the top one. So we know we can't have single bonds in there because we've already established that with our alkanes. So it's got to be something different. Okay? So what might this be a clue to, what this might have in it? So it's not single bonded because we've done that already. Okay? So let's just try it. Where do you want that triple bond? Okay, after the second one. Then we can presume that these are all single bonded now. Okay, how many more bonds does this carbon want? Okay, there's 3 hydrogens, so we're down to 5 now because we've taken 3 away. How many hydrogens on this carbon? It's a trick. 0. How many on this carbon? 0. How many on this one? Okay, so now we're up to 5. So how many are left? There is our compound C5H8, and it is an organic family called what? Alkynes. Because this is what's telling you that it's an alkyne. Now, just like every other time, what is our parent chain here? Okay, so there's our prefix. It's got a double bond. It's an organic family called alkynes, so our suffix then would be what? Just like our suffix here, even though we don't have the S, there's our organic family. Now here is our organic family. We just need to change that ever so slightly though, because this isn't quite correct. Okay, we just need to say where that double bond is located, and we're not putting anything after that number 2 there, so we can presume one of 2 things. Either 1, it's naming where the organic family is located, like alcohols, or in this case, is the organic family of being a triple bond. So it's referring to that YNE. We going too fast? Front row, are we good? Second row? Third row? Okay. So what could you presume that might be the case with this bottom set of carbons? It's going to be a double bond somewhere. Where do you want that double bond? Okay. So we'll just presume you meant the first one here. So then the rest of these are all single bonded. We've got 10 hydrogens to deal with. Okay? So how many hydrogens can go on this carbon? What about this carbon? just 1. Okay, this carbon, so we've got 3, 5, 7, and 3 more gives you 10. So that's got to be correct. So what is our parent chain? And then what is our organic family? It's an alkene, so our suffix is what? Can we just leave that as pentene? Yes, we can. But there's nothing wrong with doing what? You can do that if you would so choose. Okay? There's nothing wrong with putting a 1 in front of there. Because what happens when you have on ring structures, especially if there's 2 derivatives on there, you have to put the 1 on there. But in this case, you could just leave it as pentene if you would so choose. Okay. Anything come to mind? I just thought this might be a good application to go over. Well, we're going to go ahead and erase this bottom one. Oh, this is an organic family known as alkenes. Okay, so we'll go ahead and get rid of this one. And we'll go ahead and get rid of this one. Okay. What about if we we were talking about this earlier, where an alcohol might be located, or a hydroxy group, or an OH. We really don't have to change this a whole lot. That's not correct. Okay, we need to get rid of this. Okay, well, I'm going to move this over. Okay, so we still have 5 carbons. Okay, can we put A and N on there? Okay, we can't put an E though, because it's no longer an alkane. Once we put that OH group on there, we are referring to this as what? It's an alcohol. So what's the suffix for an alcohol? OL. It's any alcohol. Now, what is the only thing we need to change with this pentanol? Where is our OH group located? On the second carbon. Okay. Again, if there's nothing written after a number, it's telling you what that organic family is located, whether it's a multiple bond, like alkenes and alkynes, or where that OH group is located, which we've already established. It's on the second carbon. Okay. Well, what about if we put this on the first carbon? We can put a 1 on here, or we can just leave it like that. Either one's correct. It's just understood that that OH group is on the first carbon. Okay. In your minds, you're speaking for your classmates now, which is more difficult? This organic chemistry or this biochemistry? Or is it about the same? This is more difficult, so spend more time on this. Okay. One of the aspects I think I wanted to make note of and go over is we want you to know just the structures of these two. You don't have to draw these, okay? You're not going to see a question on there that says draw the structure for alpha D glucose. That would just be, I would say silly, but it's not that you can't do that. You could. But one of the things that a lot of my students will hear a lot is if we had what do I want to say, a gallon of material, and in your brain there are 3 quarts of available volume. Does anybody know how many quarts are in a gallon? There's 4 quarts in a gallon. So in short, this is your cranium. We're just trying to keep this simple. This is how much information we could put in your cranium. That'd be the abbreviation for quarts. Then here, we're trying to pass along not just 1 gallon, maybe we're trying to do 5 quarts of information. We're trying to pour this into your brain that can hold this much. Once you reach the capacity of 3 quarts, what happens to everything else? If you keep pouring that, it's just going to run over, and you're just not going to be able to maintain that. Again, it doesn't mean that you can't or that you won't, but it's just a lot of information. So that's what we like to speculate with this. But, so, again, we just want you to know the structures of this. But we're going to make one addition to it because it's just too important to leave out. And I'll get back to that in just a moment. Does anyone think they know the structure of this carbohydrate / monosaccharide? That is glucose. Okay? So what happens if we typically like to draw these side by side? Is that the same molecule? I'm trying to color code it. This is the color black. This is the color purple. But when we look at this, this has a formula of C6H12O6. If we count all these up, it has C6H12O6. How can these not be the same compound? They got the same formula. Yeah, they would be isomers of one another. The structure is different. So in this case, what's our second carbon, that hydroxy group is down. On this second carbon, what's the OH doing? It's pointed up. That can change some of the properties that we're referring to. Okay? Because if we it wasn't quite accurate what I had mentioned to you yesterday. We said some people may be lactose intolerant, which is essentially true, but it's actually when you put these two together that's in the sugar milk, not just this one alone, that people would be lactose intolerant. But that doesn't change anything. The only thing that we want you to be able to decipher, okay, that must be glucose on the right. So I'll put GL in here for glucose, okay, and I'll put GA in here for galactose. Now, what is certainly possible is we may do something like this. Oop, wait, that's not correct. Yeah, that's what I meant to do. Yeah, there we go. That's just a different carbohydrate, just a different monosaccharide. We're not even going to label that, okay? But we might throw that in there, just like on some of your vocabulary evaluations, you might be given 15 questions, but then how many terms would you have to select from? Maybe 16, sometimes 17. So this would be an application of that. We want you to be able to recognize. You don't have to draw them. We just want you to be able to recognize that. Okay, so we'll go ahead and get rid of this. The addition that we're going to put on here is actually this sugar. Oh, that's not right. Although these are fairly similar, okay, because they've got this CH2OH that's on the upper left-hand corner, but this monosaccharide is just too important to leave out because it is this monosaccharide. So with your vocabulary evaluation, okay, there was an abbreviation on there that we didn't want you to associate this. You could. But that wasn't one of your selections written like this, was it? It was, you're shaking your head no, which is correct. What was your specific selection? DNA. So where does that come from? Okay. Notice this is based off of this sugar, ribose. Okay. So this is the sugar ribose, but when we talk about deoxyribose, that means that at another one of these sites, this one right here, when we say deoxyribose, it just means that one of those oxygens is taken off, and it's at that site that this is deoxyribose, and this is the sugar ribose. That's the only difference. So if it says deoxyribose, what does that mean? You're missing a what? What did we take off here? What's this element right here? OXY. Yeah, if it's deoxy, that means that this is missing an oxygen. So we call that deoxyribose. And that's where this comes from. Deoxyribose nucleic acid. Of course, this is it's inside of you. It's your DNA. Okay? You could say it's what makes you who you are from your parents, and maybe a few years down the road, if you decide to get married and start a family, you are passing your DNA on to the next generation. I think it's just way too important of a concept to not place in here. Any questions over that? Again, you're not going to say or see draw the structure to deoxyribose. It's not going to say that. It might say what is the structure for deoxyribose. And what you would do is say, oh, at this site it's missing an oxygen. That's all it's saying. Nothing more than that. Okay, we're up to about 24 and a half minutes. Is there anything else that you would like to go over, or would you like to reflect upon your own problems that you wrote down throughout this chapter? My question is, have you pretty much had enough, or Are you all right?
I just have a question.
Yes.
Do we have to write out those vectors?
Only if it has an asterisk next to it. Because these are called what?
Yeah.
These are amino acids. Do these amino acids have anything in common? Yes.
Base.
They have the exact same base, just like what you're saying. You are not wrong when you say that. So if you're not wrong, you must be correct. So yes, you are correct when you say that. Okay? So what can you tell me? Go ahead and pick out one of those four.
Top one.
Okay? So even if we said we're going to draw valine, we're going to draw glycine, we could draw valine too because they all have the same base that they all have in common. So there's a middle carbon. So then how do we illustrate the organic family of an acid when we say COOH? That means carboxy group or acid.
Double bonded oxygen.
Double bonded oxygen. Okay, and an OH group. That is a functional group of an acid. Okay, so then this is attached to a carbon here, which we know they have to have 4 bonds. Now on the left side of our amino acid. This is the right side. What's attached to the left side now? A nitrogen. And I just do that by habit. Okay? And 2 hydrogens. That's right. And again, the reason I put these up here is just good review. Nitrogen is in which column? Which one? Not the 6th, the 5th. Okay? So that means it has how many valence electrons? Okay? So the valence electrons are located one here, one there, there's 2, there's another one, there's 3, then there's our 4th and 5th ones. An amino side of our compound and an acid side of our compound. This is where they all differ or differentiate themselves. Is this an amino acid right now? Yes. Which one? The one you asked, yes, glycine. Okay? Do we have to reinvent the wheel to draw alanine? How do we change glycine, which is this, to alanine? Add a carbon.
And then 3 more.
Okay. And then also as a review, this is how we started to learn that, inside this box, what is the formula of that molecule? CH3, which is a what group? It is a methyl group. Okay. Again, we still don't have to reinvent the wheel if we want to change this alanine to valine.
Add 2.
Okay? And I know what you mean. I could have said, what do you mean? This? No. Okay? So we would put a carbon here and a carbon here. Now we've got valine. Okay? Does anyone want to take a guess on how we draw cysteine? We're going to take these 2 carbons off like you just said. Okay, we're going to add an S here. That's right. Okay. Now you might be saying, well, if you really wanted to be specific, okay, and you don't have to do this, but again, dot diagrams, we're doing that. You're just not applying this because carbon's in the 4th column, nitrogen's in the 5th column. Sulfur is in which column? The 6th one. So it has how many valence electrons? Okay, so there's 2, there's 4, here's 5, and here's 6 because it's bonded to that hydrogen and it's bonded to that carbon. So you're still using these valence electrons. You just don't realize it. Okay. How would you know that that's cysteine other than us just telling you? Yeah. So isn't that where maybe myself and any other teacher goes like this? Shh. What are we viewing? The Sistine Chapel. That's a good way to remember that. Okay, so we will continue with this tomorrow. So the rest of the time is yours. All right, catch up to you next time.